Oh, the struggle bus is real. It's 3:30 on a Monday. You guys have a quiz coming up, probably next Monday. Here's your practice sheet for it. So you'll have to figure out the inverse of that. I'm going to work on this one, a similar question. Everything's about the same. Step one is to swap x and y. And then we isolate. We isolate the logarithm. We're going to subtract 4. And since the logarithm is isolated, I'm going to use this, and I'll have to use this a lot all over this little quiz. A logarithm base b argument a has an equivalent inverse b to the e equal to a. So I identify my pieces. My base is a 2. It will be raised to the x minus 4, and that will equal y minus 5. Now I'm going to solve for y. 2 to the x minus 4. To isolate the y, I add 5. And I don't leave it as a y. I have to rewrite that as the inverse of f of x with that notation after the negative first power of x. It's not a hard problem. Number 2, I think you guys will do well on if you can remember a formula. It's about investing. And it says I invest 7.9% compounded monthly. My formula for this is the compound growth formula. Principal times 1 plus r over n to the n t. Since I'm compounding monthly, I know that n is 12. Oh, still compounded monthly. I need to be down on a similar example. I'm going to do that a lot. N is 12. As a decimal, that's 0.092, and I'm going to invest 7 grand. That's my principal. And that's my time. I want to know how much money I have after all those years. Yeah, I'm plugging into this again. The amount after 32 years would be the principal of 7,000. 1 plus 0.092 over 12. And the exponential space would be at 12 times a 32. If you're using an older calculator like an 82 or an 83, you just got to wrap that. On a newer one, you don't have to. So let's push the buttons and see what we get. Should be a good chunk of change. 9% interest is pretty good. If somebody's going to offer you 9% interest, you go borrow every dollar you can. It's pretty good. $131,457.31. And again, that's the similar example. That's how you do your problem. Number 3, what rate of interest is required to triple an investment? My similar is quadrupling. I'm going to leave the time frame alone. Actually, let's change the time. 9 years. All right. Compounding continuously was mentioned, so the formula is PERT. I'm going to use PERT to do it. So what I'm going to do is I'm going to let my principal be something small like $1. After time, it becomes, since I'm quadrupling, $4. Doesn't matter what numbers you make up, it's just these are small. So 4 equals 1 E. I don't know what R is, but I chose 9 years. That's your setup. I would use a technique called ln both sides. So the natural log of a 4 is the natural log of e to the 9r. I like 9r better than r9, so I did a rewrite. Exponents go out front. Natural log of 4 is 9r, natural logs of e. Natural log of e, by the way, is understood to be 1. So I don't even need that there. R is going to be the natural log of 4 divided by that 9, because I would counteract multiplication with division. And I just go push buttons. ln 4, I can type ln 4 divided by 9. And that is the rate of interest required to quadruple your money in 9 years. That would round to 15.4%. All right. In a similar example, you're going to take out $112,000 to buy a new F-150 Raptor, 6.5% interest, 60-month loan. What's the entire amount you're going to be paying back? That's the compound interest formula. Talks about how interest is compounded, monthly, so forth. So I'm going to write down the formula for compound interest, and I'm just going to plug into that. It's a 60-month loan, which, by the way, is 5 years. The amount owed in 5 years is the principal of $112,000, 1 plus the rate of interest, 0.065 in my example. It's compounded monthly, and I'm going to raise that to the 12 times 5, which is the 60 that a lot of y'all want to plug in the right spot, or the wrong spot. So how much money do I owe? A whole bunch. I would never buy a brand new F-150 Raptor. I'd never actually buy a Raptor. I'd rather have a big old 350 or 450. That's what I got to pay back. I got to pay back $154,875.54. And this is a 60-month loan. All right. What's your monthly payment going to be? You take that grand total and you divide it by 60. That's your monthly payment on your car. It is exact. Well, we're going to say it is exactly, because we're going to round the nearest penny. 2581.26. That's what you got to pay per month. Teachers don't drive brand new F-150 Raptors. There's some teachers that are just starting out that probably don't make that much a month after taxes. Here's an expansion, and the rules are pretty simple. If an argument is in the numerator, the logarithm remains positive. If in the denominator, the log is negative. So let's expand that one. This one's got a whole bunch of pieces. Looks like it's got 5 pieces to me. Whoops. I'm putting those multiplication symbols in there. I'm going to have a log base 3 of 27 plus a log base 3 of x squared, because those things are in the numerator, plus a log base 3 of z. Now I'm going to start working on the denominator. These things are in the denominator. They're going to be negative. Take away a log base 3 of 8. Take away a log base 3 of y to the 4th. Now, this thing right here, that's 3. That is, what power of 3 creates 27? It's 3. And it even says, if after breaking apart, see if a log can be evaluated. If you don't know how to read a logarithm, you can use change base. ln 27 over ln 3 is going to be 3. So that leading piece is a 3. Here we have exponents. All those exponents, they go out front. Plus 2 log base 3's of x, plus a log base 3 of z, minus, this is asking what power of 3 makes an 8. It exists, but it's not a number you know. It's not a number you're going to write down because you'd round it. It would be a rounded number. So we're just going to leave it alone. And I have a 4 here, so I get to move it out front. That's how I do my similar one. And I'm going to stop on 6 for the day because I'm tired. Completely condense this logarithm other way around. If it's positive, it's in the numerator. If it's negative, it's in the denominator. First things first, those have to be moved. And this one's kind of special. I don't even need to move the exponent. The natural log of e is 1. So negative 3 ln of e is negative 3. I don't even know what I want. Yeah. No, this is a condensing. Forgive me. We're just going to leave it alone. It's condensing, so it doesn't matter if I evaluate the number. It's going to be condensed. What I should have wrote there is I should have wrote a negative 3 to throw you off, but I didn't, so I'm not going to. Let's just write that as negative natural log of e cubed, and this one becomes natural log of y plus 2 squared. Those matter. Before you do the condensing, you have to take your factors and express them as exponents. This is going to be a giant logarithm. The deal is, if you're positive, you're in the numerator. If you're negative, you're in the denominator. So 3z, this logarithm is positive, stays up top. We have an x, put an x up top. And then we have this y plus 2 all squared goes up top. Those are all the positive logarithms, so they all go up top. What goes down low? I forgot to move that 3, didn't I? V cubed goes down low. What else goes down low? That e cubed goes down low. And that is the full condensation of that logarithm. And on that note, I'm done for the day because I just want to go to bed.